Hello girls, and today we're going to be doing analyzing lines of fit 4.51.
Alright, thank you, Will.
What did he say?
We're going to analyze lines of fit.
Oh yeah, analyzing are good, yeah.
You're good.
Yeah.
Alright, so yesterday we had a set of dots, and we would put in a line by hand. And the guideline was, well, just put in a line, use your ID, use a ruler, just do it the best you can. Try to make it so it looks like it's in the middle. Well, we can figure out how good of a line did you put. Like, if these were your points, and you put a line like that, I would say that's pretty good. If you had a line like that, not as good. So what we're going to do is, how do we measure how good of a line did you do? That's what we're looking at. So the first thing we're going to look at is what's called, looks like a fancy word, it's very easy to do. It's called a residual.
Residual.
So on your notes, it says a blank is the difference. You want to fill in residual. A residual is the difference of, and then you have another blank,
Y value.
of the y value. It's the difference, so it's the subtraction between the y value of a data point and the corresponding y value on, now you have to fill in the last part, using the line of fit. The y value found on the line of fit. All right, I think in words that's a little confusing. The picture, I think, makes it a little clearer.
So basically the line is the line.
Let's say this was a data point. Okay? You had a table, you graphed that point. You had another table, you graphed that point. And you said, you know what? Here's another point, here's another point. I'm going to draw a line right there. Okay? Using my ruler, using your ID, whatever you have.
There you have it.
Okay? Look at this. Here's the point on the line. And then if I go down, here's the actual point that was in your table. How far apart are they?
2.
2. So what that means is your line is 2 units off. That's not bad. 2 units. Let's look at this one. Here's the actual point. If you go down, there's your line. How many is that one off?
3.
3. All right? So the 2 and the 3, that's what we call the residual. It's just how far off is your line. And your line can't be perfect, right? You just draw it the best you can. You're never, if you've got a bunch of points like this, you're never going to draw a line through all those points. Okay, so any questions on what a residual is? It's just comparing where your point is to where the line is, directly below it or directly above it. Okay? Okay, a residual can be one of a few different things. Okay, so on your guided notes, it says a residual can be positive. Okay, a positive residual means that your data point is actually above the line. Above, think positive. A negative residual is when your data point is below where the line is. Below is negative. And then let's say you had a third point right here. Well, that's a 0 residual. Your point is right on the line. It's perfect. Okay. So the goal, when you're drawing a line of fit, if you have a residual of 0, that's the best. As your residuals get bigger, that's not as good. Okay, small residuals, that's the goal. All right, does everybody have that?
Yeah.
Okay. All right, so the way we're going to set this up is we're going to use a table. Now, sometimes the table is going to have X, Y value from model, residual, going left to right. Sometimes it's going to be like this. X, Y value from model, and then residual, going up to down. It doesn't matter which way you do your table. Do it up to down, do it left to right, it doesn't matter. I'm just going to explain right now how you fill this table in. Okay. So, you have some bullets under your table. Okay, so under the table, first thing you want to fill in under the first bullet, the X and Y columns come from the data in the problem. So where do the X and Y columns come from? They're going to give you data in the problem. What do you mean you're going to give us data? Let me show you an example, then I'll come right back to that page. There's an example. They're giving you X values in the problem. They're giving you Y values. There's your X's and Y's. And you can kind of see how we're going to fill them in.
Yes.
Okay.
Oh, you know problem.
So the X and the Y values, you don't have to do any work at all. Just copy them down from what's in the problem. Okay. Next column you have to fill in is the Y value from the model. What does that mean? You're going to look at your line. You're going to find the point on the line. That's the number you need to write down. It's either directly below your data point or directly above it. One or the other. So the Y value from the model is the Y value you get when we plug in X into our line of fit. So this means we have to find the line of fit, okay? And we did that yesterday. Sometimes they'll give it to us. I think in some problems they give it to you. So Y value from model, the way you're going to calculate it is you're going to plug in something into an equation. Okay, we've got to figure that equation out, or they might give it to us. Okay, last column. This is the easiest one, the residual. All you have to do is subtract. Subtract. If I number the columns, subtract column 2 minus column 3. So you're gonna have a number there. You're gonna get a number there. Subtract them, and then just write the answer in column 4. Okay, now on your sheet, you should see a little thing next to that that says graph of residuals. So sometimes what we'll do is we will graph our residuals and see, are they really big or are they really small? That's how you graph them. So put that right on the last line below the third dot. This is only if they ask you to graph. Okay, not every problem is going to have you graph. Some will, some won't. Okay, and it's a little confusing, I think, to just write the steps without doing it, but now we'll go through it, and I'll show you it's really not too bad. All right, so now everything else we're going to do on residuals. Mr. Roy and I have already made charts for you, so you don't even have to draw the whole chart by hand. Some of it's already filled in for you, so you don't need a ruler. It's going to be pretty easy. Just flip over to the back. All right, so this problem right here, this is the same problem we did yesterday. Do you remember the one we did at the end of class about, I think it was selling DVDs, and then how many weeks later, how many DVD sales we had?
Yeah.
This is the same problem. So to save time, that's the equation we had yesterday. I'm just going to stick with that same equation. Okay? Just that way, we've already done it from yesterday. What's up, Jack? Your question? Oh, Mr. All right. So that's the equation we came up with in the end of your notes. That's what we're going to start with right now.
Alice. We're guessing.
All right. So
You guys, your graph on yours is a little bit different in terms of like the table's a little bit different, like the X and Y. The X and Y go across as opposed to down. That's all.
I just set it up that way, Mr. White, so it's kind of like coordinates.
Yeah.
So they see it that way.
Yeah.
That's all. All right. So here's the table. That's the same table that was in your notes from yesterday. Okay. Let's look at our columns as we go across. What's X's in this case? What does it represent? Weeks. And what's Y?
Sales by millions.
Sales in what? Millions, exactly. So week 1, they didn't make $19, right?
They made 19
They
million.
made 19 million, exactly.
Wait, is this like a movie?
Yep, it's the same one
Yeah,
we did
same question,
yesterday.
but it's figure out something different, that's all.
All right, so now what we're going to see is how good is our line of fit? How we came up with that yesterday. How good is it really? Okay. So in the X column, you guys already have these filled in going across
Yeah, so
1 through 8. Now, what's the next column we're supposed to fill in after the X's?
Y.
The Y's.
The Y. No.
So now the Y's are already filled in for you, and I want you to think of them as coordinates. Right? 119, 215. I'm not going to do this to all of them. 313. Just think of them as coordinates. Okay, on yours it's up and down. It's not left and right.
Yeah, I checked this one.
Now, the Y value from the model. What is the model? What's the equation?
Y equals -2x.
There you go, right there. That's the model. So let's go back and look at our directions. The Y value from the model is what you get when you plug in X into the equation that Xander just said. So let's start. What's our first X value? 1. We're going to take 1. We're going to plug it in. And we're going to write down what we get. Xander, what's -2 times 1?
Me? Which one?
X.
-2.
-2. And then, Xander, what's -2 plus 20? Think of our arithmetic warm-ups we've been doing.
17,
Think of it as 20 minus 2.
18.
18. That's the Y value from the model. Now, the Y value should be 19. We got 18. In a minute, we'll write how far off it is. I'm sure you already know, but we'll write it down. Next one. My next X value is 2. Plug it in. Jack, what's -2 times 2?
1, 8, 1.
Negative. Well, -2. What's a negative times a positive?
Negative.
Negative. What's 2 times 2?
4.
4. So -4. And Will, we've got -4 plus 20.
-4 plus 40. 16.
16. Good job. Again, the Y value from our model is pretty close to what it should be. It's not off that much. So we're doing good. Next one, let's plug in 3. Ginny, what's -2 times 3? -6. I'm just going to use my calculator this time. -6 plus 20. 14. You might notice a pattern. We could kind of guess what do we think the next one's going to be. 12. Let's check it. 4 times negative 2 gives me negative 8. Let's use our calculator. Let's add 20. And we get 12.
Was the next one going to be 11?
Oh, we're going down by 2. Yeah. Next one's 10.
Would you say negative 4 times 2?
That's 11.
What's the next one?
It's gonna be a what? I
6, 4,
Joe, next one?
It would be 6.
6 and 4.
I thought we were subtracting 2.
We haven't done the subtraction yet. We're going to do that right now. So now the residual, that's where we do the subtraction. Column 2 minus column 3.
So guys, in your case, because it's 7 rows, it would be like row 2 minus row 3.
So just basically put a minus sign right in. Well, if it was vertical, just put a minus sign right in there and do this calculation. What's 19 minus 18? 1. Put a minus sign right in there. Okay, I'm not going to keep doing that because I know you can't. What's 15 minus
Guys,
16?
you already have it set up like vertically up and down, so you just put a minus sign from up and down, so 19 minus 8.
You know what?
negative 1.
Good?
Yeah.
13 minus 14?
Negative 1.
Negative 1. 11 minus 12?
Negative 1.
10 minus 10?
0.
That's good. 0 residual means your line is perfect for that one. What's 8 minus 8?
0.
7 minus 6?
1.
5 minus 4?
1.
1. So looking at that, that's pretty good. Right? Look at your residuals. At most, your line is only 1 unit off from where it should be. That's great. 1 unit above or 1 unit below. In some cases, it's perfect. Okay. So now the last thing we're going to do is we're going to graph those residuals. Okay, how do we do the graph? It says the plots on the graph are of the form x, comma, residual. Okay. Here's your column. Let me just get rid of these. X, comma, residual. Okay, so let's write these down. Look at the first row. What's my x value in that row? 1, comma. What's my residual in that row? 1. So right now, I don't care about these 2 middle columns. Just the first column, last column. Or in your case, first row, last row.
Where are we writing this?
We're going to put it right on this graph right here.
Where are we writing the coordinates that you just wrote?
You don't have to write it.
Okay.
Okay? So we're going to graph 1, 1.
Oh, then do you go up again?
1, 1. The next one we're going to graph 2, negative 1.
Where are you getting this from?
I'm circling 2,
Oh,
negative 1. Right there.
this makes sense.
So 2, negative 1. The next one,
It looks funny.
3, negative 1. 3, negative 1. Someone tell me the next one.
4, negative 1.
There you go. 4,
5, 0.
negative 1. Yep.
6, 0.
All right, you tell them to me. 4, negative 1. 5, 0. 6, 0.
7, 1.
7, 1.
8, 1.
8, 1. That's a graph of your residuals.
See, it looks weird.
Yeah, it looks weird, but they're all pretty close to this line right here, aren't they?
Yeah.
They're either 1 unit above or 1 unit below. That's perfect. If you had a graph and you had residuals like way up here, that means it's way off from where it should be. That means the line that you drew, not that good.
So you need to scroll back up real quick. So you just graphed it. Thank you.
Okay? So I know it's kind of a lot of steps to get used to, but once you get used to it, the actual arithmetic, super easy.
So guys, just because your chart was set up a little bit differently, I think as I walked around, people looked like they were okay. Just so everybody's on the same page. Yours is set up like this, right? Going down, X, Y, Y value from model, and residual. Right? So on your notes it said to get the residual, it said column 2 minus column 3. but yours is set up in rows. So you just do row 2, which is the y's, minus the y value from the model. So and they're on top of each other, so just minus them, right? That's how you get the residual, row 2 minus row 3. When Mr. Hager graphed it, the only thing you have to graph is the original x, which is this column, and your residual. That's how you determine if it's a good fit or not. So you're only graphing that when you graph it, the original x coordinate and the residual that you get. So the residual becomes the y. Right, so like I said, your chart's set up a little bit different, just to make sure everybody's okay with that. I just want to make sure you guys understood. If you want to kind of add some of these little notes to your chart, you can. If you feel good with it, you don't have to. Okay?
Okay, so last problem on residuals, and then we'll finish up with that thing I told you about with the calculator earlier. It says the table below, which you already have in your notes, shows the ages and salaries of different employees at a company. So somebody that's 35 years old, does it say they're making $42?
$42,000.
Thousands of dollars, right? 42,000. Somebody who's 47 at this company makes 51,000. And they already gave us the model. That's the model right there. Yep. So a lot of times in these problems, Joe, they're going to do that.
You guys, we're always going to give you the model, and chances are on the chart, those first 2 columns, the x and y, I know for your chart, the x and y row are always filled in. It's going to be up to you to fill in the y value from the model and the residual on your own.
Okay, so how many columns do we have to fill in on this table we've been making? How many columns on this table?
8.
This table right here.
824.
Oh, 8.
Wait, never mind.
Count.
4.
Oh, 4.
1,
4 by 8.
2, 3, 4. 4 columns. So, on yours, I think it's set up as 4 rows.
Yeah.
What do you already know?
The x,
Yeah.
y,
The x and
y.
perfect. So we already know those. How do I get the y value from my model? What do I have to do?
You have to
Plug in the x. Where do you plug it in, Gemini?
X.
Right there. So because it's a decimal, I'm going to use a calculator because that's going to be hard to do. What do I type into my calculator?
0.2
All right, give me 1 second. 0.2 times
what's the number? 35
35.
These numbers are kind of big.
equals plus 38.
And then plus 38. And where does 45 go?
On the y. Yeah.
And if you want, we can do the residual at the same time.
Did it just say that 35 times 2 was 7?
Yeah, it's
0.2.
Oh, it's 0.2.
So it's -3. I didn't see the point.
You are correct.
I told you I'm long and see people.
Okay, and then 42. Okay, guys, Savannah, I need everyone up here. 42 minus 45, -3. Next step. Who can tell me the next thing I have to do?
You're gonna take 37.
Take 37,
Plug it into x,
plug it in for x.
and then you're gonna solve the equation.
All right, so take 0.2 times 37. 7.4, you know what? Just leave it like that. And then plus 38. 45.4, where do I put that?
In your y value of y.
And now, just pretend like there's a minus and subtract. 44 minus 45.4. That gives me negative 1.4. What column does that go in?
Residual.
The residual.
Oh, wait.
Okay. Do you guys have calculators?
No.
No.
And then you're gonna give us the really fancy.
We're gonna do that after. Give me 1 minute, and then we'll come back to finishing this up, or Mr. Roy, if you wanna go through it,
This one here?
just to finish this column. Okay.
Alright guys, so we got, next one's gonna be, calculator up here somewhere, there we go. Maybe not, there we go. What are we gonna plug in next?
41.
And
Plug it in.
multiply times 0.2.
So 0.2 times
41.
41,
Insurance and there's an actual.
then what? Add 38, good. 46. Now what do I do?
90, 47 minus 46.
Yeah, 47 minus 46.2. So we get 0.8. All right, next we got. All right, guys. So once as we said, do people get kind of the hang of what we're trying to do here?
Yeah, you're just plugging in X and then everything comes out.
Yeah. So again, like the way yours is set up, right? You have it on top. You have it on top of one another, right? You have the X. You have like we did over here. You have the X. You have the Y. You have the Y value from the model, and then you have the residual, right? So first thing you have to do is, like you guys just said, plug in, right? Take the X value, plug it in, right? Once you do that, that's going to give you the Y value from the model. Then you have those numbers stacked on top of each other, right? The X and the Y, the Y and the Y value from the model. Subtract those two things. That's how you get the residual. Now when we graph the residuals, what are the only two things we're worried about? What two columns should we be looking at to graph the residuals?
The last two.
Not the last two.
No, you're looking at the X. Wait
Yeah,
a minute,
good.
I wrote it down in the Y.
Not the Y.
What?
The X and the, what do we just figure out?
Oh,
The residual.
mod.
Yeah. So when you're graphing it, you're not graphing like Mr. Hager was telling you guys earlier. All right. He said we want to make this a coordinate. Yes, the X and Y. But we're not worried about graphing that coordinate. The only thing we have to graph is the X and the residual. The X is your X coordinate, the residual becomes your new Y coordinate. Now someone tell me, by raising their hand, how do we know if it's a good fit or not? What's going to tell? So now we've graphed everything. How are we going to know if it's a good fit or not, Josiah?
If it's like a close number, like if your module thing was 14 and your
That's
residual
47.4.
was like 15, that's good. Or
Yeah.
if it was,
Yeah, if the numbers are relatively close together when you graph them, and you look at the graph and all numbers are kind of relatively, a couple lines away from the middle line, that's good. Right? It's kind of like yesterday. Yesterday we did a line and fit. That was your estimation, right? We had to like draw the line. We wanted to kind of get the number of dots to kind of be balanced on the top and the bottom. We said it wouldn't be exact. It's just, we're doing the same kind of thing here, but this is going to give us the exact line that's going to be the best fit. The exact line.
Well, that's what we're gonna do next.
Yeah.
Yeah.
I don't like how it's decimal.
But,
It makes it more
so guys, all this is telling us is if it's good or no good. All right.
I did a couple more rows, guys. Just
Yeah.
copy that down.
You guys get, and guys, if we're asking you to do something like this, probably on a homework or a test or something like that, we're not going to make you. We're going to make the numbers come out nice. We're not going to make them come out as decimals. But again, it's for
Because
practice.
decimals are hard to put on the line.
Exactly. We're going to give you nice numbers that come out so you can graph them.
So now, which two columns do I use to do the graph?
He said the X and the
First and
residual.
the one.
He is correct. 35 is about here, down 3. That's your first one. Now the next one is 37. So just estimate the best you can. 37 down 1.4. Well, that's down 1. Maybe about right there. The next one would be 41, and what's the other value?
-1.4.
41.8. So not quite up to 1, but kind of close. The next one, 43, then 43,
3.4.
43, 3.4. I'm just guessing,
Yeah.
because 3, a little bit higher than 3. 45, all right, that's easy. That one's right on the line. 3.6. Well, 3.6 is a little bigger than 3.4, so try to make it a little higher. And the last one, 47, 3.6. So about the same height as the last one. So are those points close to this horizontal line?
No.
No, they're much further away than if I go back to this one. This one was much better. They were all 1 unit away. These are like 3 units away, almost 4 units, 0.8, -3. This line is not as good because the residuals are bigger.
What do we call it?
It's just not as good of a fit, that's what you'd say. So Mr. Roy was mentioning this idea of best fit. So when you draw a line by hand, okay, if you do something, does everybody have this table? If you do something like this, and you say, all right, I'm going to put a line kind of like that. Got 3 points above it, 2 points below it. That's just an estimate. I didn't do any math there. I didn't do any calculation. That's just by my eye what I think a good line of fit is. So the last thing we're going to talk about, what's that? So the last thing we're going to talk about is what's called a line of best fit. There is a calculation you can do that would make the most perfect line that you can possibly have. It's not a guess.
With no flaws?
It's as perfect as it can be. Now, in this class, we are not going to learn how to do that calculation by hand.
Oh, okay.
We're going to learn how to do it using a tool that can help us, okay? Using the calculator. That's going to tell us the answer. How it does it, I'm going to save that for another class because the calculation itself is a little tough, okay? But what the calculator is going to do is give us the best possible line for a set of data. Like mathematically, it's the best you can do. It's not a guess, okay? And that's called a line of best fit. The process of creating that line is called linear, notice the word line in it, linear regression. Okay, that's the name of what we're going to do. If you ever take like a statistics class, you might learn how to do linear regression by hand. I am not going to show you that. I'm going to show you how to do it on a calculator.
Why?
So why? Because the calculation is really hard to do by hand. It's a lot of steps. On the calculator, very easy. Very easy. You just have to watch me use the calculator. So this is the best line that you can have. Okay, does everyone have those 2 blanks? Linear regression, line of best fit. Yep, now I'm going to give you a calculator.
I'm kind of excited. Yeah.
Okay?
Window.
Window. Yours has words on it?
Yours says,
Bro.
all right. So now, I don't, oh yeah, go ahead. I want you to do this. I want you to press stat. Where the heck is stat?
So how do we go to edit? Do we press enter?
I found stat.
You have to watch me press the buttons first. And then if you have a question after, there you go. Stat is right below delete. It's right near
Oh
the
my
arrows.
goodness, it's saying stuff.
Yep, it should say stuff.
There's one go. I would appreciate it.
All right. So when you press stat, does everybody see that screen?
Yes.
Yeah.
We're good?
Yeah.
Okay, what's the next thing it says to do on the screen?
Go to edit.
Go to edit. Edit's the first choice. So if you haven't pressed anything else, all you should have 1 highlighted. If it looks like this, the wrong thing is highlighted. Does everybody have the number 1 highlighted?
Yes.
Touchscreen.
Okay? No. It is not touchscreen.
Press enter.
Not yet. They're gonna make some.
Press enter.
How come you have
Oh, it's spooky.
Now, across the top, you should see 3 things. You should see an L1, you should see an L2, you should see an L3. And it should look just like that. Does anybody's not look like that?
Looks like we're playing the old thing.
You're good, Fred? You good? All right. Now, There's a screen again of what you should see. Everybody sees that? Okay. Next step. We're going to type in our x values. What are our x values? I haven't given them to you yet.
35.
I'm going to give them to you right now.
20.
Your x values.
I said no decimals.
Yeah.
Well, the calculator is going to do all the work. You don't have to do anything.
Oh, we gotta work.
Okay, I'm going to show you how to type those in. Okay, hopefully you haven't pressed anything yet, right? Okay.
No.
So on the calculator, should look like that. Press 2.0. Don't press anything else yet. And now, does everybody have 2.0 at the bottom?
It says 20 on the
Yeah, mine says 2.0.
No, like
It tastes like chlorine.
Once you press 2.0,
Press enter.
press enter, and you should just see the number 2.
that is so
So why didn't we just put 2?
Yeah, you could have just put 2. That's okay.
So now do we do that?
Now the next one, 3.7. Hit 3, hit point, hit 7, and now what do you think you're going to press?
Enter.
Wait. How do I clear something?
Wait, do I-
Because I accidentally didn't put
Can you watch
enter.
that? Is this thing-
You know, I'm just gonna put all of it in.
Okay, what's the next one after 3.7?
Oh, yeah.
4.2. What do I hit? Enter.
1.9 enter.
2.5.
2.5 enter. 4.5.
1.9.
Great, you made me put 44.
What's the next one?
3.1.
No, I'm going to have to help you fix that.
I got it.
I'm getting the hang of it.
What's after 1.9?
3.1.
Not 31. 3.1.
2.5.
Next one?
I said not 31. 3.1.
2.5?
I did it 4.4.
4.4.
3.9.
Now, it might look like it's like, well, wait a minute, where did the first ones I go typed in? They're still there. It's just,
the calculator.
yeah, the screen can only show so many at one time. Okay, so just, that's perfect. Does everybody have all those numbers that I haven't read?
Oh, I already go to L2.
I'm going to talk about L2 in a second. So we've got those numbers in L1. Anybody not have those? You good, Fred?
You get rid of
I
something.
put 4.4 in front of 3.9.
That's okay. Just leave that number. Okay, so now, we just typed in which values, the X's or the Y's?
Oh, no good, bro.
X. So what do we still have to type in?
L2.
The time.
We still have to type in the times.
So that's L2.
And where does it say to put them?
Alright, I'm doing it.
I would do that.
Wait, how do I go to L2?
All right, let me show you how to go to L2. If your screen looks just like that, press the right arrow.
I did.
And now you should be in L2.
No, I'm still in L1.
And you press the right arrow?
Yeah.
Oh, she did not.
I'm precious.
Right.
It was a joke. Psycho.
That's the left
I know I am.
You were in L3. Okay, Joe, in L2, what's the first number I put in?
It's
60. So I press 60 and then what?
enter.
Enter. How many do I have to type in? I gotta type them all in. What's the next one?
83.
83.
81, 58.
Yeah, I can't go that fast. What's the next one after 83?
84.
84. Next one?
Yes. 58.
58. Next one?
72.
72.
62.
62.
And then 85 twice.
And then 85 twice. 85. 85.
So what do we read for L3?
L3, you don't even use it. We don't need it.
Why?
No way.
Oh, that's messed up to L3.
So
If
first-
I said that to me, I'd be mad.
L3.
Let me make sure that everybody has this step so far.
Yeah.
How are we doing with L1, L2?
So what is L3 then?
L3 just stands for list number 3. We don't need it because we only have 2 lists of numbers.
In what case would you have a
If you had a third list,
Why?
like if you had X, Y, Z, we
do
don't.
that?
No, we don't.
Okay, good.
Noah?
I accidentally put 1 for 8 for 3.
You put 1 in for 3?
Yeah.
All right, we can just delete it.
I pressed clear and it's not working.
No, it won't. You have to press delete. Yep, there you go.
D-E-B-R-A-H.
All right. Does everybody have that in L1 and L2?
Oh, you're doing that.
Okay. Next step. Okay, guys, I need you up here because now you've done the hard part. Now we're going to do the easy part.
I said tweet like for 2000.
After typing in all your data, everyone typed it in?
Yes.
Okay. Read the directions.
Press that.
Press, let me bring up my calculator. Press stat. You should now see this screen. Does everybody see this screen?
Why did you go back to that?
We have to go back to that. Press stat. Okay. What's the next thing it says to press?
Press the right arrow.
Press the right arrow to go to what?
Calculator.
What does it say? Go to
Calculator.
calc. So you press the right arrow.
Good job on your guys' game.
Okay. Does everybody's screen look like that?
Yeah.
Okay. Next thing. In the list, select the option that says LINREG. Right there. LINREG. How do you get to it? Press the down arrow.
What do we do when we get to?
Don't do anything yet.
I pressed something.
There's 2.
Don't press anything yet.
Wait.
Okay? So everyone should have number 4 highlighted.
Yes.
Okay. Hit enter.
Okay, good. I was like,
Hit. Enter.
Plus B.
Now you should see that on the screen.
check out yours.
Does everybody,
Guys, don't check out your
guys, it's okay. They have to check out. It's good. I like
Tell us
it.
what to do, alright?
Why?
Shut up.
Guys,
Whoa.
watch the
That's not
language,
nice
please.
word.
Does everybody have that? Mr. Roy, can you handle her something?
Test here.
Guys, LINREG. Does everybody have that on the screen? Thank you. Now you should see that it says hit enter again. Okay, hit enter again. Just once. Okay. Now, when you hit enter, did anybody get that?
Yes.
Yes. Excellent. That anybody not get that? If you typed in a different number, you might get something
What
different.
number are we typing in?
It says A is 11.99 and B is 35.1. How many people got that? Raise your hand if you got that. Good. So what's A pretty close to?
12.
Basically 12. Let's just call it 12. Let's go back to the screen. B is pretty close to 35. We'll call it 1. B is 35.1. Now, let's look at what the calculator just gave us. Not that calculator, that one. A is the letter in front of X. What letter do we normally put in front of X?
No, MX.
MX. We normally put an M. This calculator used an A. So A is taking the place of M, and what's M? Slope. So this is the slope of the perfect line that goes through that data. The first number is the slope.
Will it come out perfect with any number?
Yeah.
Or is it?
Yeah, it'll always come out as perfect as it can do. So A is the slope. And what about B? Exactly, that's the y-intercept. That's the most perfect y-intercept you can
Should
find
I write this down?
for that problem. Yeah. So how would I write my final answer? Y equals
A, I'm supposed to
Why?
y equals, and what are we going to fill in?
35.
12.
X.
Yeah.
Plus 3.5. 3.5. I thought you said
35.1. That is the most perfect line that you can have that would go through that data. That's not a guess, that's perfect. That's the most perfect slope, that's the perfect y-intercept. You can't get it any better than
Since
that.
we're done, can I press round?
You don't have to press anything else. You're done now.
What can I see?
Well, I'm gonna have you try one more on your own, typing in the numbers and doing what we just did.
Wait, no.
I'll help you.
It doesn't even work.
Yeah, it's not gonna graph anything. Okay, any questions though on those two numbers?
No.
All right,
Oh, no.
so I'm gonna have you guys try one more, but just a reminder, test is gonna be on Friday. Okay, if we have an early release tomorrow, we will have to just cancel the MCAS question.
Or we have no school tomorrow.
Is that good?
Yeah, same thing, if there was no school tomorrow, we will cancel the MCAS question.
Okay.
So we will still have
How
a,
about this early?
Well, we have a test Thursday.
we would still have a test on Friday, Thursday would just not be a review day.
Wait,
That's-
whoa.
It changed.
That
No.
changes things. Why don't we have?
Don't, that's what I wrote, and I wrote, that's wrong.
Why can't we
So
not
we
have
don't get a
tests?
review day.
Why?
Yeah, if there's no school, no review day.
Or, no, guys, we have an early release, we're not gonna have class tomorrow. So that means obviously, same
So let's
idea,
do
we'll
But then
do,
how do we have a reference sheet?
we'll have a we'll still have school, we'll still have class.
Wait, are we getting
on
snow
Thursday.
tonight or tomorrow?
Tomorrow.
Guys, let's just be clear on this, we're all on the same page. Because my sources tell me that either we're not gonna be here tomorrow, or there's gonna be an early release, one or the other. So it's probably like an 80% chance that we're not gonna have a full day of school tomorrow. Either there's no school, or there'll be an early release. If there's an early release, that means we get dismissed, like a half day. We get dismissed at 11. So that means we will not have class. Alright? Not have class at the end of the day, we meet 7-8. So plan on this. If there's no class tomorrow, whether there's no school or early release, there's no review day. There's no MCAS problem. We'll do the new stuff, guys, hold on. We'll do the new stuff, the last section of new stuff, or the last half of the section of new stuff on Thursday. Alright, if you have any time at the end of class, we'll review, and the reference sheet will be posted, so you'll still have access to the reference sheet to work on that for Thursday night for the test on Friday.